For this lesson, we're going to look at the unit normal vector, and we're going to develop a shortcut for doing this in 3-space. And we're going to again look at the vector valued function r of t is t squared, t cubed. So what is the velocity of t? That, of course, is the first derivative at t, which is 1, 2t, 3t squared. How about the acceleration at t? That's the second derivative at t, which will be 0, 2, 6t. For our discussions, though, we're interested in what's happening at 1. So what is v of 1? V of 1 is 1, 2, 3. How about the magnitude of v of 1? You get the magnitude of v of 1. It's the square root of 1 plus 4 plus 9. So the magnitude of v of 1 is root 14. Well, that gives me t of 1, right? That gives me t of 1. T of 1, of course, is velocity divided by speed. So that's 1 over root 14, 2 over root 14, 3 over root 14. And how about I get a of 1? What's the acceleration at 1? Well, 0, 2, of course. And then 6 times 1 is 6. Then what do we remember? The tangential component of acceleration is a dot t. So I'm interested in all of this stuff at t equals 1. So at t equals 1, a dot t is a of 1 dot t of 1. So a sub t will be 0, 2, 6 dot 1 over root 14, 2 over root 14, 3 over root 14. So what's that going to give me? 0 plus 4 over root 14 plus 18 over root 14. So we get a sub t is 22 over root 14. So I know what a is. Again, before we said a of 1 was 0, 2, 6. How about the magnitude of a of 1? What's the magnitude of a of 1? Is the square root of 0 plus 4 plus 36. So the magnitude of a of 1 is root 40 for now. So I have the magnitude of a of 1, and I have a sub t. So what can I do with that? I can use that to find a sub n. So let's remind ourselves of that process. So here's some relevant information, and we recall that a sub t squared plus a sub n squared is the magnitude of a squared, and a sub n has got to be positive. A sub n is bigger than 0. So a sub t squared, 22 over root 14 squared, plus a sub n squared is root 40 squared. So squaring 22, I get 484. Root 14 squared is 14, plus a n squared is 40. So a n squared is 40 minus 484 over 14. So I get a n squared is 38 over 7. So a sub n is root 38 over root 7. And I think I'm going to rationalize the denominator. That's going to make my life just a little bit easier. So what do I get for a sub n? 38 times 7 is 266. So we get a sub n is 266, root 266 over 7. Here's the relevant information we need next. Remember, our goal is to find n of 1. So can you think of the strategy you're going to need to do that? How am I going to find n of 1 using all of this information? Well, our rule then is going to be a of 1 is a sub t times t of 1 plus a sub n times n of 1. A of 1 is 0, 2, 6. A sub t, 22 over root 14, times t of 1, 1 over root 14, 2 over root 14, 3 over root 14, plus a sub n, root 266 over 7 times n of 1. And our goal, again, is to find n of 1. So where does that put me? 0.26 is now root 14 times root 14 on the bottom. That's going to be pretty nice. That's 22 over 14, 44 over 14, 66 over 14, plus root 266 over 7 times n1. Now I've got to subtract all of these components from that vector to see where that goes. So 0 minus 22 over 14, 2 minus 44 over 14, 6 minus 66 over 14. Simplify those fractions. What do we get? So it brings us here, which we can see we're just about finished now. Multiplying both sides over 7 root 266 times negative 11 sevenths, negative 8 sevenths, 9 sevenths is going to equal n of 1. So then how does this thing finish? Where are we at? Negative 11 over root 266, negative 8 over root 266, 9 over root 266 equals n of 1. Much faster than the first time we did this problem.